Hello everybody, it is nice to meet you again in the class of Mechanics and Strength of Materials. In the previous module, we already discussed about the concept of the stress. The effect of the stress is the strain. So, in this segment, we will discuss briefly about the concept of the strain. In this figure, you can see a bar is in the tension test. So, the bar is pulled by the certain value of the force. Before the loading, we draw three lines as you can see in the slide. There is horizontal line, the vertical, and also the diagonal line. We want to see the change of these three lines when the bar is in the tension. You can see that in the right side, the length of the three lines are changing, which means there's a change of the bar of the shape and the size. So, we can say that whenever a force is applied to a body, it will tend to change the body shape and size, which is called as the deformation. So, in order to describe the deformation of the body by change in the length of the line segments and the change in the angle between them, we use the concept of the strain. Just like stress, there are two types of strain. The first one is the normal strain, and the second one is the shear strain. Here, I will introduce to you about the normal strain. In the slide, you can see a body. Before the force loading, that's the point A and also the point B with distance of delta S. After the loading, the body is deformed, as well as the point A and B now become A axon and also B axon. Now, the distance between A axon and B axon is delta S axon. From the changing distance of delta S and delta S axon, we can define the normal strain as delta S axon minus delta S over delta S, as long as the B and A is along the normal line. The effect of the normal strain is the change in the volume. The second type of the strain is shear strain. Shear strain talks about the angle. So, in the slide, you can see that there's a point A, B, and C on the body. Line AB is perpendicular to line AC. After the force loading, of course, the body is deformed, so that the ABC point now become A axon, B axon, and also C axon. Of course, the line of A axon, B axon is not perpendicular anymore to A axon, C axon, but their angle is theta axon. So you can see that there's the deformation, which means there is the strain, the shear strain. So, in general, shear strain can be seen as the change of angle before and after deformation. The shear strain can be defined by pi over 2 minus the theta axon. So, you can see the gamma and theta here is, you can assume just like the change of the angle. Different with the normal strain, the shear strain causes the change in its shape, not in its volume. That's all for this segment. In this segment, we have discussed about the definition of the strain, and we learned that there are normal and shear strain. In the next segment, I will give you the sample how to calculate the strain of the body. So, please stay tuned. Thank you for your attention and see you again in the next segment.